Our next problem deals with diluting solutions. And the concept with working with solutions is we can have concentrated solutions which we can add water to or add solvent to dilute them to a lesser concentration. Not unlike when you buy orange juice in the frozen concentrate can. That's a concentrate because it's a concentrated solution. To prepare your orange juice that you drink, you dilute that with 3 cans of cold water. That's the directions for diluting that solution. So we do a lot of solution dilution in chemistry as well. And when you're doing dilutions, an equation that can be useful is the one that's written here. So the idea is that we have what we call stock solutions. Stock solutions, if you hear the word stock solution, that represents a high concentration solution that we can dilute to make a solution that's of lower concentration. And so here's the equation that your book has. The molarity of your diluted solution times the volume of your diluted solution is going to equal the molarity of your concentrated times the volume of your concentrated. And the idea is we're not changing the quantity of stuff that's there. We're really just changing its concentration and its volume, whether we're diluting it or concentrating it. So I'm just going to show you an equation that I've used. It's the same concentration, but we refer to it as M1V1 equals M2V2. Just easier to say and to write. So again, that's the equation we're going to want to use. M1V1 equals M2V2. Okay, and so to read this problem, it says isotonic saline, that's actually what you'll find in an IV bag, is a 0.15 molar aqueous solution of sodium chloride. How would you prepare a 0.8 liter of isotonic saline solution if you had a 6 molar stock solution? So it asks basically how we prepare this. And when we have an equation that has multiple variables, we'll get to this especially as we move through some latter chapters that have a lot of equations with multiple variables, so not doing as much unit conversion. What I like to do after I have my equation here is I like to write the individual variables here, and then I like to identify which ones that we know and which ones we don't know. Where does the problem want to take us to solve this? So the key here is recognizing that whether you call the concentrated one 1 or 2, we have to kind of identify these together. So I'm going to always refer to as my 1s as being my concentrated solution. So we know that our concentrated solution or our stock solution has a molarity of 6.0 molar. Now, they don't tell us how much of this that we want to take. So this is going to be our unknown, but we know we want to make a diluted solution that's 0.15 molar, and we want to make 0.80 liters of this. Okay, so hopefully everybody can see that it makes sense that when we dilute a solution, we're going to decrease the molarity. But what should happen is as we dilute a solution, we're going to increase the volume that that solution is contained in. So we call this an inverse relationship, right? In order to maintain this equality, we'll have this inverse relationship that as we dilute a solution, so if our 2s are diluted solutions, our concentration will go down, but that means our volume must go up in order to maintain this equality. Okay, so now that I know what my variable is that I want to solve for, you can go about this problem in 2 ways. You can actually put your values in right now and then solve, or sometimes I find it easy to solve where all I have is variables right here. So V1 is equal to M2 times V2 over M1, right? I just isolated the variable that I'm solving for, and then I can put in the pieces that I have. And this is why I like having this little list over here, because it makes sure that I put things in the right spot. So 0.15 molar. My second volume is going to be 0.80 liters. And my M1 is going to be 6.0 molar. Again, units will cancel here. I'm left with units of liters, which is what I should have for units of volume. So again, that makes sense. Work out the math here, and we get 0.020 liters. Okay, so this is 20 milliliters. And this should make sense, right? If we talk about taking a stock solution and diluting it, that means we're going to take a smaller volume of this stock solution and mix it with water to make a larger volume of our diluted solution. So keep in mind too, this problem says, how would you prepare? So we actually need to answer this question. So we got an answer that told us something, but now we need to answer the how part of this. So how would you prepare this solution? you would dilute 20 milliliters of the 6.0 molar stock solution to a final volume of 800 milliliters, right? That's what 0.80 liters is, with water. Now keep in mind, this is really important. We dilute the solution to a final volume of 800 milliliters, okay? We do not add, so we do not add 800 milliliters, right? Because then we'd actually end up having 820 milliliters of solution, and that's not what we want. Okay, so we don't add 800 milliliters of solution there. We make a final solution that has a volume of 800 milliliters. Remember that molarity, really molarity is, and if we look back at our last problem, we can remember this, molarity is really the moles of solute per liters of solution. It's not liter of water that we add, it's the total volume of the solution. Okay, so there's a little bit of a descriptive part to fully answer this question. Calculation to find the volume that we dilute. So then we dilute 20 milliliters of that stock solution to a final volume of 800 milliliters with water.